All right, geometry students, we are going to start with our section on similar polygons. So the work that you did, the last section should be like prep work for this section, so it shouldn't be too bad. So our essential question is, how are similar polygons related? So we're going to go through a couple different pieces of information. The first one is corresponding parts of similar polygons are equal. So a similarity transformation preserves angle measure. That's really important if you want to highlight that in here. Let's see if I can get a good highlight in here. Corresponding angles are congruent. It also enlarges or reduces side lengths by a scale factor, which we call K. So corresponding side lengths are proportional, which is why we did that work with proportions yesterday. So the one on the right here is showing all the corresponding angles that are congruent, and then also the ratio of corresponding side lengths. If you set up your ratios with the, in this case, the red triangle on the top and the blue on the bottom, when you divide the two side lengths, it should give you that that scale factor K. So let's go ahead and try this right away. Example 1 says, can you find the scale factor from ABC to JKL? So that's important. The order in which it lists the two triangles. So it says from ABC to JKL. So if you think about it using logic, right, our triangles are getting larger. Our triangle is getting larger, right? The side lengths are getting larger. So to find the scale factor, we're going to put the second triangle listed on the top and the smaller one on the bottom. And when I say that, I mean we're going to set up a ratio of corresponding side lengths to find our scale factor. So ABC, JKL, so they are already set up so they kind of mirror each other, or they like look like each other. You have to be careful and make sure that the triangle is not turned any which way, so make sure you find the appropriate corresponding sides. So in this case, we're going to put 28 over 21. And when I divide those two, or reduce the fraction, I end up with 4/3. That is our scale factor. Now, if you wanted to check to make sure you did it right, we could pick any other two sides. So I could pick these two sides that I circled in green and set up 36 over 27. That's also going to equal 4/3 when I reduce. And then also this 48 over 36. 48 over 36. So they all should end up with the same reduced fraction or scale factor if you do it correctly. Now, the hardest thing for students is they will put the sides in the wrong spot, either the numerator or the denominator. So if you think about it, from ABC to JKL, if the triangle from one to the other is getting larger, we know that the scale factor needs to be greater than 1. If our triangle was getting smaller, then our scale factor would be less than 1. Okay, so this one's pretty easy. It says, it's the same example. I just had to re-put it on the second page. It says, list all pairs of congruent angles. So we're just finding corresponding angles here. So we can use what they named. So they named the triangles ABC and JKL. So you know that A and J are corresponding, B and K are corresponding, and C and L are corresponding. So angle A is congruent to angle J. Angle B is congruent to angle K, and angle C is congruent to angle L. So that's all we have to do for that. And then the last one says, write the ratios of corresponding side lengths in a statement of proportionality. So we're going to find corresponding sides, which we already did on the last one. So, but we're actually, instead of using the value of the side length, we're going to use the letters to name the side. So in this case, we're going to write JL is over AC. So that's just this side and this side. That ratio is equal to, I'll go ahead and change colors, JK and AB. And I want to make sure if I put the JKL on one side or on the top, I do that for all of the ratios. So JK over AB is also going to be equal to the last pair of sides, corresponding sides, which we're going to name KL and BC. So those are the corresponding side lengths that ratios are equal. And this is another core concept. So if two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of similar polygons. So we just wrote that out, basically. These would all equal our scale factor. Okay. Okay. So the next one says, in the diagram, triangle GHM is congruent to HKL. Find the value of X. So GHM and HKL. So they're already, the corresponding sides are pretty easy to find. So like 10 is corresponding with 15 in red. I'll just outline these so you can see. So here and here are corresponding, here and here are corresponding, and here are corresponding. So there's a couple ways to do this. The first way we could do it is just set up a ratio and then cross multiply and divide. So let's go ahead and do that. So I'm trying to find X. So I'll put X here, which is KL. I'll even write KL above it. The corresponding side to KL looks like it is 12 here, HM, 12. That's going to be equal to, and now there's lots of different ways to do this. I can pick either two of the other sets of corresponding sides. So I'm going to go ahead and pick 15 over 10 because those are just a little bit nicer numbers to deal with. And now I can cross multiply and divide. So I would end up with 12 times 15 here would be 180 is equal to 10x. And then if I divide both sides by 10, I end up with x has to equal 18. I actually feel like this is how I would do this, and I'm going to show you just in case this is how your brain works. What you could do is take two corresponding sides and find the scale factor. So in this case, our scale factor is 3/2, right? So I just did 15 divided by 10 is 3/2. Now if I take 3/2 times 12, because that was my corresponding side from the smaller triangle, I would end up with 18. So either way that doing that works. Okay. And then this one says, in the diagram, UVW is congruent to QRS. Find the length of the median of ST. So if you look, these two triangles, the one on the bottom is flipped vertically. So these sides are actually, I'll go ahead and highlight them. So this side is congruent to, or sorry, is similar to this side. So we can use the ratio of 36 over 12, right? 36 over 12 is going to be congruent to 36. Oh, excuse me. Whoa. I'm trying to do this shortcut and it's not working. Okay, hold on a second. So I know I can do it two ways. I can add these up. It's actually not necessary. I can just leave it as 16 because, yeah. So I can do 16 over 12. So this is the half of the base. Is going to be equal to 36 over x. So 12 represents the median. X represents the median we don't know. And now we can go ahead and cross multiply and divide. So 36 times 12 equals 432 would be equal to 16x, and then divide both sides by 16, and we're left with 27. So if you watch the original video, the teacher that did it added these two together and these two together when they set up the ratio, but it really doesn't matter. If you keep them both split in half, you're going to end up with the same answer, the correct answer. Okay, so here's a theorem. It's called the perimeter of similar polygons. So if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So basically what we're saying if in like the simplest way, if, ooh, if this polygon had a perimeter of 10 and the scale factor was 2, so say everything was double in length, then the new area or the new perimeter of the similar polygon that's 2 times as large would be 20. So basically, if you multiply all the sides by the scale factor and add them up, it's like you just multiplied the perimeter times the scale factor. That's what this is saying. So here's our example. It says your neighbor has decided to enlarge his garden. The garden is a rectangle with a width of 6 feet and a length of 15. So let's go ahead and sketch this. So 6 by 15. Okay, there's the garden. The new garden will be similar, but the length is going to be 35. So this is going to be 35 instead of 15, and they need to know the total perimeter. So there's multiple ways to do this, right? You could set up the proportion, find the missing side length, and then take 35 plus whatever the side length is, plus the side length again, right? And I'll go ahead and, I'm going to do it the way I would do it. What I would do, because now that we know from that theorem to be true about perimeters, is we can find the scale factor. So let's go ahead and find the scale factor. 35 over 15 equals 2 1/3, so 7/3 if we reduce this. So this is our scale factor K. So if I take 7/3 and multiply it by the perimeter of my original garden, which is 15 plus 15 plus 6 plus 6, so that would be 42. So 42 times 2/3, I end up with, times 7/3 is 98. Okay, so that to me is like the way that's most efficient. What you could do now instead is set up a proportion, right? 15 over 6 equals 35 over x. We're going to cross multiply to get 35 times 6 equals 210 equals 15x. Divide both sides by 15. And you're left with x equals 14. So now we have 14 over here, 35 and 14, and then we could add up 35 plus 14 plus 14. And guess what you're going to get if you do that? I'm just going to double check my math here. It's going to be 98. So you can do it that way, or you can do it the way that I did the first time. That either way is fine. Okay. This one is, I'm going to come back to this one. So skip this one. I'm going to come back to it because it's the most challenging in my opinion. Okay, I just realized that this probably didn't go, this just like keeps the slides in the right order. So now we're just doing this, so it's fine. But okay, again, areas of similar polygons. So if two polygons are similar, then the ratio of their areas is equal to the squares of the ratio of their corresponding side lengths. I do not like this formula. I can show you, I'm going to show you how to use it, but I don't like it. So in the diagram, which wasn't on here, so I had to draw it. So you're going to need to sketch this diagram. It says that PQT is similar to RST, and the area of RST is 75 square meters. So I'm going to write 75 in this triangle over here, right? They gave us a side length of each. Find the area of PQT. Okay, so the smaller triangle we'll go ahead and put on the bottom. That's the area is 75. The area of the larger triangle we don't know. So I'm going to call that A because it's the area. What this formula is telling you is that the new area is going to equal the ratio, the squares of the ratio. So what it's saying is we need to take the ratio of the two sides. So we're going to put 10 on the bottom, because that goes, that's the side length that is on the triangle that has an area of 75, and then 14 on top, and then we need to take the square of this ratio. So we're going to do that first before we cross multiply and divide. So we can rewrite this as A over 75 equals 14 squared is, I always forget this one, 196, is it? Yeah, 196 over 100. So I'm just I just squared the numerator and squared the denominator. That's all we need to do to take the square of this ratio. Now we can cross multiply and divide. So 196 times 75. So I have 14,700 equals 100A, which is the area. Divide both sides by 100. And I'm left with the new area has to equal 147. Okay, so the area of this triangle is 147. I don't like this way. So this is going to get a little lengthy. If you feel good about this, you can stop it now. If you're like, that didn't make any sense, Miss Moore, I want to explain to you how to do this in a more efficient way, in my opinion, okay? So I'm going to go ahead and erase this because we already know this. Sorry, I'm going to erase all this. Maybe, if I can figure out how to do it. Uh-oh, my pencil's dying. Oh no. Example 6 says decide whether GNMH and MLKH are similar and explain your reasoning. So remember, even though these two rectangles are attached, someone's going to say, well, they're not similar because one is way smaller than the other. Well, it's really about the ratio of their sides, right? So if I look at the longest side of the first rectangle, which is right here, right? My sides are 25 over 10. We have to see if that equals the longest side of my smaller triangle, or rectangle, which is right here. So that would be 10. And then my shorter side would be 4. So we need to see if these two are actually equal. The easiest way would be to do cross products and see if they equal each other. Well, 10 times 10 is 100. 25 times 4 is 100. So yes, they are similar.